The most important sed command is sed s/old/new file. This replaces the first occurrence of the word old on each line of the file with the word new. In this example, sed invokes the sed program. S specifies sed's S command for substitute. Slashes delimit the command from its two arguments. The word old represents the text that is searched for, and the word new represents the text that replaces it. Note that the whole S command is enclosed in single quotes. I'll explain more about that later. Here's an example of sed's S command in action. We'll start with our dukeofyork.txt example file. So the sed command is sed s/lowercase the to all caps the dukeofyork.txt. Again, note that the entire S command, including its arguments, is enclosed in single quotes. Note that sed is always case sensitive. So in this case, we've replaced lowercase the with all caps the, but it did not catch the initial cap the at the beginning of the first line of the file. Note that it has replaced the first lowercase the with all caps the on each line. It does not, for example, change the in the hill on line 3 to all caps. It's important to note that sed does not actually edit its input file. I'll cat the dukeofyork.txt file, and you'll see that the original file has not been changed by the substitution performed on the previous line. If you do want to modify the file, you can take that sed command and redirect the output into another file, for example, gnu+txt. So now if I cat gnu+txt, you'll see that the modified output was saved in that file. The replacement text in this case is 3 letters, the same as the original text, but this does not have to be the case. The replacement text can be shorter. For example, we can change marched to ran. Or the replacement text can be longer than the original. We can replace men with women. The replacement text can even be empty. We can replace them with nothing. So you see here, it's removed the word them, but you can see that there are still 2 spaces where it had been. The basic command sed s/old/new file reads from the file and writes to standard output, but you can specify more than one file, in which case they are read in order. For example, sed lowercase the to uppercase the dukeofyork.txt and array.c, pipe the result through more. So here we see the Duke of York file with lowercase the replaced with all caps, immediately followed by array.c with lowercase the replaced with all caps. See, there is an example in the middle of the screen. You can also omit the file. If we said s the to the with no file, it processes the standard input. You can use Control-D to terminate that standard input. Omitting the file argument like this is generally used to process the output of some other program in a shell script. For example, we can use the nl command, which simply numbers its lines, pipe the output of that through s the to the with no file argument, and you see that the line-numbered output of nl has then been transformed by sed. Sed can also be used as a filter within VI or Emacs to perform more complex transformations than a simple search and replace. We'll go into those later in this course. Finally, as with any other Unix command, sed can take input from a file with the pointy bracket. For example, we can say change the to the, take the input from dukeofyork.txt, and put the output in output.txt. And we cat output.txt and see that the modified Duke of York has now been stored in that file. The sed command that we've been using so far, sed s the to the, doesn't need to be quoted. For example, if you omit the quotes like this, it works exactly the same as it did before. But quoting sed's command argument is a very good habit to get into. Quotes are needed in case the command contains a space or a character that is special to the shell. For example, sed s the to some of the in dukeofyork.txt. This example changes the first the in each line to some of the. But if you omit those quotes, it doesn't work. It fails with an error. Here's another example. We can change 1,000 to $1,000. This changes 10,000 men to $10,000 men. But if you omit the quotes, it changes those $1,000 men to 0 men because the $1 was replaced with the value of the variable 1, which is the first argument of the shell itself, which for a login shell is an empty string. Note though that if you get into the habit of using single quotes, apostrophes can bite you. For example, if we try to sed were to weren't, see, at this point, the shell is not even accepting that. In this case, you see there's an unterminated string constant. The problem is that the apostrophe in weren't closes the quoted string, and the following apostrophe opens another one. If this happens to you and you get that pointy bracket prompt, you can press Ctrl+C to terminate the command. If you do want to use an apostrophe within a SED command, you can enclose the command in double quotes instead. You can double quote, change were to weren't, and this time it works. In general, you can use double quotes around a string that contains single quotes, or vice versa, but you need to keep in mind that the behavior of double and single quotes is different. The most significant difference between them is that within double quotes, $signs are still special. For example, you can use double quotes to change 10,000 men to $10,000. But in this case, because we used double quotes instead of single quotes, the spaces in 10,000 men were properly preserved, but the $1 was expanded to the value of variable 1, which in this case is nothing. So the quotes do protect the spaces, so this is a valid SED command, but they do not protect that $1 from being evaluated as a variable. What can you do if the string includes both types of quote, or if you need to use both apostrophe and $sign? In either of these cases, you must use double quotes with a backslash to escape, or remove the special meaning of, any special characters in the quoted string. For example, suppose you wanted to change were to $weren't in quotes. We'll do sed, we'll put it in double quotes, s/were to backslash double quote, backslash dollar, weren't, backslash apostrophe, t, backslash quote. Now we have a slash to terminate the s command, and then a quote to finish quoting the whole string. So in this case, the backslash is used to remove the special meanings of the double quote, $sign, apostrophe, and second double quote within the quoted string. So in this case, we've replaced all occurrences of were with $weren't in double quotes. Note though that you cannot use backslash quote to escape a single quote within single quotes. This does not work. Within single quotes, every character except single quote, including backslash, stands for nothing but itself. You see here, the shell does not respect that backslash single quote as being anything other than just another single quote. Finally, note that it's also possible to use the backslash to avoid using quotes at all. Just use the backslash to escape any spaces, $signs, single or double quotes, or any other characters special to the shell. For example, we can say s were to weren't, backslash apostrophe, backslash space, really, slash. So in this case, we've used the backslash to escape the special meaning of both the apostrophe and the space, to change were to weren't really. Note that weren't really contains the apostrophe and the space. The backslash simply removed the special meaning of those characters to the shell. In general, it's best to get into the habit of enclosing SED's command argument in single quotes and only use the techniques that we've discussed here in special cases. By itself, the S command affects only the first occurrence of the initial string on each line. You can add a G modifier for global to the end of the command in order to affect every occurrence on the line. For example, in this case, we've added a G modifier to our replacement of lowercase the with uppercase, and so now it affects every the on the line. I'll clear the screen. The G modifier looks for non-overlapping occurrences of the initial string. For example, if we replace ABA with dash 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 globally on every line in the standard input, if we give it the input AB, 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 A, it only replaces some of the ABAs with dashes. Now why is that? The first substitution affects the initial ABA on the line, which means that the second ABA, beginning in position 3, is no longer there. The next remaining ABA begins at position 5, and so on. This non-overlapping behavior can have unexpected consequences. I'll clear the screen again. For example, suppose you wanted to insert a hyphen between every pair of lowercase a's in the file. You might try something like this. We'll replace AA with A-A globally in the standard input. But given the input of a line of a's, it does not replace each pair of a's with A-A. It seems to skip every other one. This is because the first substitution uses up the first two a's, which means that the second a is no longer available to pair with the third. Terminate the input, clear the screen. Note that the G modifier is not recursive. The S command only scans the input, not the result. For example, if we try to replace they with and they in our Duke of York file, note that it replaces they with and they, but it does not go back and replace that they with and they again, resulting in and they, and then and they, and so on to infinity. However, if you use multiple S commands, we'll discuss this later, each one does scan the output of the previous ones. Clear the screen again. In addition to G to affect every occurrence of the initial string on each line, you can use a number to specify the nth occurrence. For example, we can change the to the second time it occurs on each line. So in this case, you see that initial lowercase the on each line has been left alone, and the second occurrence of the on each line has been replaced with its uppercase equivalent. In cases where only one the appears in the line, for example, and he marks them down again, there's no change. The number does not have to be a single digit. Clear the screen. For example, we can replace A with a dash the 40th time it occurs in the standard input. So we'll give it a whole line of A's, and you see it replaces the 40th A in the line with a dash. Use Control-D to terminate, clear the screen. I'd like to point out here that the slashes in the S command don't have to be slashes. They can actually be any character as long as all three of them are the same. For example, instead of a slash, we can use a semicolon. Replace the with uppercase the globally in our Duke of York.txt file. Note that this works exactly the same as if you'd use the slash, as long as you remember to use the quotes. You can keep this ability of SED to use a terminator other than the slash whenever you need to include a slash in the search replacement string. For example, if we wanted to replace half with 1/2, you can do it by using a delimiter other than the slash. If you tried to do it using the slash, as you usually would, it causes an error. This doesn't work because the slash after the 1 terminates the replacement string, leaving that extra slash hanging around at the end, which is not legal. Alternatively, you can // to escape the delimiter. For example, we can change half to 1 //2/. So in this case, the / is used to remove the special meaning of the slash within the string 1/2. And this works exactly the same as if we'd used a different delimiter.